Okay, so these are the last 3 examples for tonight, and they're on solving rational inequalities. And we had already gone over that you do not solve inequalities. You assume that you are looking at an equation, which requires an equal sign. So I'm changing it to 8 over x plus 3 over x minus 1 equals the number 3. Now, it's fractions, they're rational. You got to get a common denominator. So, a factor of x is missing from the 2 on the right. So I have to include a factor of x and include a factor of x. But also, a factor of x minus 1 is missing from the left and the right. So I have to include a factor of x minus 1 and include a factor of x minus 1. Now the denominators will all match in factors. So the adjustments to the numerators are x minus 1 on the top left, x in the middle, and both x and x minus 1 on the top right. Now before I pick up an eraser and eliminate them, this is undefined, and I'll put it up here. When the denominator, the common denominator, is equal to 0. I'm hoping everyone's okay and can just look at it and say, oh, you can't have x as 0 and you can't have x as being 1. Those values are out. All right, so I saved a little space by not showing each individual one equal to 0 and then solving. But the common denominator can now disappear. You only use it for the adjustments in the numerator and for the undefined. So now, going to the problem, I am looking at 8x minus 8 plus, I'm looking at 3x equals, and 3x times x is 3x squared, and 3x times negative 1 is negative 3x. On the left-hand side, there are 2 like terms, which gives me 11x minus 8 equals 3x squared minus 3x. But this is a quadratic, so you have to move the 11x over, but you also have to move the 8 over. When you have a quadratic, one side of the equation has to say 0. Combining like terms, you get 3x squared minus 14x plus 8. Now you knew it was coming. I put in one that requires the poof method. So even though I'm going to solve this problem correctly, to the left-hand side, I'm going to think of it as x squared minus 14x, and 3 times 8 is 24. The factors are not too bad. The numbers that multiply to 24 and add up to 14 are 12 and 2. Remember, the first sign you see goes in the first parenthesis, and a negative times a positive is a negative. Larger number goes first, smaller number goes second. But that 3 in the front has to go in front of each one of these. The GCF on the left is 3, but there is no GCF on the right. So what are the true factors? Well, the left one tells me x minus 4, and the right one tells me 3x minus 2. Your job is to set each one of those factors equal to 0 and solve them. The one on the left is x is 4. The one on the right is x is positive 2/3. Now, you just finished solving the equation, but you're required to solve the inequality in black. So you have to do that with a number line. So the real answer to the problem is all the way at the bottom. The answers that you get have to go on the number line. Here's 2/3, here's the number 4, the undefineds of 0 and 1 have to also go on. Here's 0 and here's 1. I think just on this problem, I'm going to make it or equal to, because the answers you got to the green, not the undefined, because the undefined always gets open circles. The answers you get follow the inequality. The or equal to requires you to fill in the 2 circles. Thank goodness for calculators, because I have to check stuff. I'm going to pick a -1, and I'm going to fill in -1 for those x's. So I have on my calculator 8 divided by -1 plus 3 divided by, and I'm combining them, -2. My answer is a negative number, and all negative numbers are less than or equal to 3, which just tells me make sure there's shading on the section that contains -1. Now, 2/3 is more than a half, so my test is 1/2. So I pick up my calculator, and remember 1/2 is 0.5 if you need to do that. So my first one is 8 divided by 0.5, and then it's plus 3 divided by, and 1/2 minus 1 is -0.5. When I hit equals, my answer comes out to be 10. And the number 10 is not less than or equal to 3. So do not shade where 1/2 is located. Now, 0.75 is more than 2/3, because this is about 0.666. So 0.75 is what I'm using because it's between 2/3 and 1. So from the beginning, it is 8 divided by 0.75 plus 3 divided by, and 0.75 minus 1 is -0.25. When I hit equals, my answer comes out to be a negative number. And all negative numbers are less than or equal to 3. So now I'm shading where 0.75 is. This time I'm picking the number 2. So I go to my calculator, I clear it out, and the first one is 8 divided by 2 plus. The second one is 3 divided by, and 2 minus 1 is 1. When I hit equals, my answer is 7. The number 7 is not less than or equal to 3, so do not shade where 2 is. But now I'm going to pick 5. That's that section. And I'm going to go to my calculator, and I'm going to type in 8 divided by 5 plus 3 divided by, and 5 minus 1 is 4, and hit equals. The number I get is 2.35, and that number is less than or equal to 3, so I am shading where 5 would be on that number line. So this answer has 3 separate parts, and that's the answer to number 4. Okay, number 5. It's an inequality, it's a fraction, you want to change it into an equation. So right off the bat, you assume that you are looking at an equation instead, which is 4 over x minus 4 equals x. Now, that does not have a common denominator, so I'm going to get it to have a common denominator. So what I need to do is just make sure this denominator has a factor of x minus 4, because if it did, then the denominators are the same going across. Put in the adjustment that you need, and as long as you got the common denominator going on, you can then look for undefined. Undefined is when your common denominator is equal to 0. And that would tell you it's undefined when x is equal to 4. That number 4 will go on the number line with an open circle above it. My equation has like terms, So you can eliminate the denominators and then clean up the problem as you see it. The left side just says 4. The right side is x squared minus 4x. This is a quadratic, so you want to move all the terms over to one side because you solve quadratics when they're equal to 0. You have x squared minus 4x minus 4. I feel like I wrote down something incorrect. I did. Okay. I gotta fix it because I do want this to work out nicely, and therefore I have a typo in this problem, but it's not going to be something that you have to change. I'm double checking quickly. Okay, my original problem, I'm going back to the black marker. Can you please make that -4 on top? Which means in purple, this is -4 over here. Which means in this greenish color, this is -4, and therefore I had to add 4 to both sides to get it to be equal to 0. I did that because the original problem was not factorable and our focus was on everything else. The factoring should be straightforward here. So my factors are x minus 2 times x minus 2. So remember, I changed the problem. I made it a -4. When you actually set each factor equal to 0, you kind of come up with just the same answer. The value of x is 2. But those are the answers to your problem. They're not the answer to the inequality, the one that was written in black on the top. So to solve an inequality, you place the solution on a number line. The answers you got in your equation, and there's only one of them, go on the number line. Since the inequality does not have the or equal to bar, it's an automatic open circle. But the undefined, which is 4, always has an open circle no matter what. So I'm going to pick up my calculator. I'm just going to tell you out loud what numbers I'm picking. I'm going to pick a 0 because I think that's going to be easy for me to work with and fill in. On the left-hand side, it is -4 divided by -4. When you fill in a 0, you're going to get +1. Is +1 greater than 0? The answer is yes, which means your job is to shade where 0 is. Now I'm going to pick the number 3. I'm just going to go to my calculator and use it. So my numerator is -4 divided by, but if I fill in a 3, 3 minus 4 is -1. When I hit equals, my answer comes out to be 4. Is the number 4 greater than 3? The answer is yes. You are shading over here. And now I'm going to pick the number 5, but I'm going to do it strictly on my calculator. So the fraction is -4 divided by, and if you fill in a 5, 5 minus 4 is 1. The left-hand side is -4. Is the number -4 greater than the number 5? The answer is no. So do not shade on that side. And what's in orange is the answer. Okay, my last one. And I will change this to an or equal to. So please do the same if you don't mind. Now, when you look at this problem, there's a few issues. First, it's a fractional inequality. We don't do that. You are going to assume that you have an equation. So the first thing I'm going to do is rewrite it as x over x plus 4 equals 11 over x squared minus 16 plus the number 2. That's the first thing. Second, anytime a denominator can be factored, I always factor it because you want to match them. My first fraction, you cannot factor the denominator. But my middle one, that's dots. So you have x plus 4 times x minus 4. And there's not even a denominator in the last one, so I'll just put a fraction line placeholder. My common denominator, well, if my first fraction had the x minus 4, then the first two would match. But my last one has nothing. So you need both the x plus 4 and the x minus 4. If you have that, you have a common denominator across the whole equation. You just got to put in the appropriate adjustments so that you have not changed any of the values. So this is x plus 4, x minus 4. All right. Before I erase any of the denominators, let's go for undefined because that's important for you to know. This equation is undefined when the common denominator is equal to 0. So that's when x plus 4 times x minus 4 is equal to 0. But I hope without me having to show a lot of work, you know that that's when x is negative 4 and when x is positive 4. So both of those numbers are going to have to go on the number line, and undefined means that they get open circles. Now, my denominators match. They're like terms. I could pretend I don't even see any of them and just deal with what is written in the numerators. So, left side, x times x is x squared. X times 4 is 4x. There is an equal sign and then the number 11. Be careful on the right-hand side because when you get x squared, you have to multiply it by the 2 in front to give you 2x squared. And when you get negative 4x, you have to multiply it by the 2 in front to get negative 8x. And when you get positive 4x, you have to multiply it by the 2 in front to get positive 8x. And finally, when you get negative 16, you have to multiply it by the 2 in front to get negative 32. You got a long equation. I'm going to first combine like terms and then move on from there. But there are no like terms on the left-hand side. The right-hand side, I'll start with the 2x squared, but a negative 8x and a positive 8x cancel out. And 11 minus 32 is negative 23. Now this is a quadratic. And if you subtract x squared from both sides, it will not cancel out the x squared. So I'm also going to move the 4x over by subtracting it from both sides also. Because all quadratics will be solved only when it says equals 0 on one of the sides. So 2x squared minus x squared is x squared. The next term is negative 4x. And the last term is negative 23. And I'm sure I had a typo on here because it should have come out to be nice and factorable, and I botched it up. But I'm going to work with what I have. All right? So I'm sorry that I put in the wrong number. But I can't factor that expression. But whenever you can't factor something, you're going to use the quadratic formula. So, to solve it, it is x is equal to negative b plus or minus the square root of b to the second minus 4 times a times c. 4 times 23 is 92. All over 2a. Now you can clean that up, and I wish it was factorable, and that was my every intention to make sure that it was factorable, but I messed up somewhere. So x is equal to 4 plus or minus the square root of 108 all over 2. And I'm not even going to simplify. I'm going to wing it. I wish I had nice values. I'm sorry I messed up. But what are my 2x values approximately? Well, the square root of 1 over 8 is close to 10. So I'm going to say 4 plus 10 is 14 divided by 2. One answer is pretty close to 7. All right. The other answer is 4 minus 10, which is about negative 6. divided by 2, the other answer is pretty close to negative 3. Okay, my apologies for putting in the wrong number because it should have come out to be factorable. But I'm still going to finish up this whole problem. I'm just going to erase all of this so I have some space to draw a big graph. And then we'll be done. Okay, so how do you actually get a solution to the problem written in black? You draw a number line because it's an inequality. The answers you get, which are close to the number 7, I'll write down the real value, 4 plus the square root of 108, all divided by 2, getting a closed-in circle. But remember, that's close to the number 7. The other one is close to a 3, so I'll put it here. 4 minus, I think I said negative 3. Oh, yes, I said negative 3. So 4 minus the square root of 108 over 2. You still have a circle that's filled in because of the or equal to bar. Remember, this one is approximately negative 3, and this one is approximately 7. I wish they came out nice, they didn't. Now, go to the undefineds. It's undefined when x is equal to negative 4. But isn't negative 4 on this side of negative 3? But it's also undefined when x is equal to 4. And that's between a negative 3 and 7. Undefined always gets an open circle. Always. So now I have a ridiculous amount of sections for me to check. I am going to my problem, and I'm going to only type in the left-hand side. And this time I'm going to write it in orange so that you see what I'm typing in. I'm going to pick the number 10. That's 10 divided by 14. If I type that in, hold on, 10 divided by 14, I'm going to get about 0.7. So I'm checking 0.7 on this side. Is it less than or equal to? And I'm going to fill in 10 over here. So what do I know? The numerator is 11 divided by 100 minus 16 is 84. And then I'm going to hit plus because there's something after it, the number 2. My answer is 2.1. The question is that a true or false statement? That is true, which means shade on the section of the number line that includes the number 10. All right, now I think I'm going to pick the number 5 to check. When I go to my calculator, the left-hand side is 5 divided by, and 5 plus 4 is 9. I'm going to get 0.5. I'll say 0.55. I'm not even going to round. So this section, I'm looking at 0.55. I'm using the less than or equal to, and then I'm going to go to the other side. The other side is 11 divided by, and 25 minus 16 is 9. And then don't forget about the plus 2. And when I look at it, it says 3.22. The question is that true? And the answer is yes. So make sure you shade where the number 5 is. Now I'm going to pick 0, because that's between any negative and positive number. If I fill in 0, 0 divided by 4 is 0. If I fill in 0, I have 11 divided by negative 16. 11 divided by negative 16 plus 2. When you look at the answer you get, you're going to get 1.3. That is true. So shade over here. Now, what's between negative 3-ish and negative 4? I don't know. I'm going to pick negative 3.5. And I'm going to use my calculator. So my top numerator is negative 3.5 divided by, but if I put in negative 3.5 plus 4, I'm dividing it by 0.5. That answer is negative 7. So the left-hand side is negative 7. It was a positive 7, sorry. No, negative 7. Is that less than or equal to what I get on the other side? Well, I don't know. First, I don't even know what negative 3.5 squared is. So negative 3.5 squared. Just, what'd I do? There we go. I want to figure out what that is first so I know what number is going into the denominator. So when I square it, it's 12.25. When I subtract 16, that denominator is going to be negative 3.75. So I'm going to type in 11 divided by negative 3.75 and then plus 2 at the end. When I finish that, my answer is going to be negative 0.93. Guys, that's true. When both numbers are negative, the one that looks smaller is actually the larger number. So this works. And finally, I think I'm going to pick negative 5. So I'm going to go to my problem, and I know numerator is negative 5 divided by, and when I fill in negative 5 into the denominator, it comes out to be negative 1. So the left-hand side is 5. Is that less than or equal to what I get on the other side? Well, the denominator, a negative 5 times a negative 5 is 25. And 25 minus 16 is 9. And then when you add 2 to it, I'm getting an answer of 3.2. And when you look at it, that one is not true. So do not shade over there.